Today we're doing lesson 6.19, division with and without remainders. All right, so we've talked about the math warm-up, and now we are on to the next page, page 173. Okay, so today's a lesson, just one lesson. Tomorrow is a lesson and then a quiz. We're going to do a quiz on this. These problems have lots of steps. I know they have lots of steps, so you really got to turn on your brain and pay attention, okay? All right, here we go. Jada used partial quotients to find out how many groups of 7 are in 389. Analyze Jada's steps in the algorithm. So Jada divided 389 by 7. When you find out how many groups there are of 7 in 389, that's dividing. Now, Brooklyn, you haven't seen the cool thing that I've shown these guys. So our multiplication tables are limited, right? They only go up so high. But we're dividing by 7. And Evan, when we divide by 7, what row do we use? The 7 row, right? And so remember, our goal is to subtract from 389 until we get as close to 0 as possible. So we want to take off chunks. And so we can add zeros behind each of these to make them bigger numbers. The only thing is, if we do it down here, we have to do it up here. And Autry asked a good question yesterday. Can we add more than 1 0 if we want? Absolutely. I think it was Autry. Yeah. And so that means on the 7 row, 7 is a multiple of 7, but so is 70. 14 is a multiple of 7, but so is 140. This helps us find multiples of 7 so that we can subtract those off of 389. Okay, so 389 divided by 7. I'm going to do it on here. And we're looking at what she did. So she first took away 280. And 389 minus 280 equals 109. What do you multiply 7 times to get 280? All right? 40. Because 7 times 4 is 28. And then we add a 0. So right over here, we're going to write 7 times 40 next to that 280. Because that 280 is the multiple, and it's the answer of 7 times 40. Now that 40 that we just wrote down is a partial quotient. It's part of our answer, right? So we take the 40 and move it up here. Then the next thing she subtracted was 49. If you go to your 7 row on your multiplication table, do you see a 49 on there?
Yes.
Yes. What do you multiply 7 times to get 49? 7. Okay, and so then she took the 7 and put it right here. Then she was left with 60 after she subtracted. And then she took off 56. What do you multiply 7 times to get 56? 8. And then she put the 8 up here. So her last step then, well, when she subtracted, she got 4. Is there a multiple of 7 that can be subtracted from 4? What's the very first multiple of 7? 7 times 1 equals 7. Can you take away 7 from 4? No. That's how you know you're done. You either get down to 0 or you get to a number that's smaller than what you're dividing by. Okay? So if I'm splitting out 389 marbles to 7 students, and I give each one 55, and I have 4 left, I can't give out the last 4 because then they wouldn't have equal amounts, right? So here we go. We can, it says look at the 3 numbers above 389. What do they represent? What did I say those were? 2 words. Begins with a P and a Q. Mary? Partial quotients. Yeah, that's a tricky word, isn't it? Quotients. All right. Partial. All right. So that last time I dropped my pen, it got jammed. All right. Partial quotients. That's the answer to number 1. Okay. Look at the 3 subtraction problems, or subtractions below 389. What do they represent? So 280, 49, and 56 are all what? Blank of blank. Autrey?
Multiples of 7.
Yes. Multiples of 7. Okay. Wait. What is another way you can decompose 389 divided by 7? So what did she split 389 into? She split 389 into 280, 49, 56, and then she had 4 left over, right? Yeah. Those were all the multiples of 7 she subtracted, right, Devin?
Right.
Okay. So we're going to do it our own way, and because you don't have to split it that way. So if we go to the 7 row, what is the biggest number? Emma, what's the biggest number on the 7 row that you see that you could take away from 389? Yes, 350. So we're going to split our 389 into 350. And what do you add to 350 to get 389? Ari? 39. And since 39 isn't a multiple of 7, I'm going to do 35 and then 4. Does that make sense? Okay, so here we're going to do it. First thing I'm going to do is take away 350 from 389. And I can do that because 7 times 50 is 350, right? And that leaves me with, 39. Then I'm going to take off 35. And 39 minus 35 is 4. And I can do that because 7 times 5 is 35. Now I'm going to take this number and this number and bring them up here. 50. 5. What's 50 plus 5, Todd?
55.
Yep, 55. So the answer to this problem is 55, remainder 4. Tomorrow we're going to interpret remainders, figure out what they mean. Okay, so here's the way we decompose 389. We did 389 split into 350 plus 35 plus 4. Then you can turn the page after you do copy down what we split 389 into. Okay, the next question says, is 389 a multiple of 7? If we're counting by sevens, will we eventually say 389, Jackson?
No,
No, how come?
because I know that 7's an odd number and it has an 8 in there and that's an even number.
No, it's got nothing to do with that, because on the 7 row, if you look, we've got a 56, that's an even number. We can't make up rules. But what happened when we did divide 389 by 7?
Not really good.
What did we have at the bottom?
4.
A remainder, right? That's why. So you're right in that 389 is not a multiple of 7. But the reason is because when we divided, we had a remainder. Okay? What?
I know it's not a multiple also because on the 7th row we added a 0 and it's not.
Uh-huh. But it won't necessarily be on there, Evan, and this is why. Because, I'm glad you mentioned that though, because you see there's a 350 on there, right? What's 7 more than 350?
357.
But that one's not on there. Does that make sense? So, adding the zeros helps us find numbers to that are bigger multiples, but adding those zeros doesn't cover all of them, like our multiplication table does on the smaller numbers. Okay? Huh? Yeah. Okay. Is 389 a multiple of 7? No, because there is a remainder. When you divide 389 by 7. Okay. You guys tired today or what?
Yes.
I didn't
I'm
want
extremely tired.
No,
At least I'm not baseball.
I stayed up until
Why is that?
Okay, all
I
right.
stayed up until 12.
That was my fault. Okay. Next it says use an algorithm that uses partial quotients to find out how many groups of 3 there are in 702. All right. So we are going to do 702 divided by 3. I can tell by looking at this that we are not going to have a remainder. Do you know why, Colton?
Because that number is even.
No. The only thing you worry, or the only rule that has to do with even and odd is for being divided by 2 and 6. Audrey?
Because if you add them all together, they don't equal 9
They do equal 9. When you add them together, 7 plus 0
because it's 7.
plus 2 more.
Oh, I said she has 6 because
Okay. The rule for 3 is if you add the digits together, 7 plus 0 plus 2, and it equals a multiple of 3, then the whole big number is divisible by 3. So 7 and 0 is 7, plus 2 more is 9. Is there a 9 on your 3 row?
Yes.
Yes. That means if we kept going, there would be a 702 on your 3 row. Okay. All right. So we're using the 3 row. I'm going to put a 0 behind the 3. I'm going to put 2 zeros behind the 6 because I want to take off as big a number as I can that's easy to subtract. Is 600 a multiple of 3?
Yes.
Is 6 a multiple of 3? Yes. So 600 is as well. And if you subtract 600, that's a big part of the 702. You're left with 102. What do we multiply 3 times to get 600, Avis?
200.
Yes. And so that 200 is our part of our quotient, a partial quotient, so we write it up top. Okay, what do you want to subtract from 102 that is a multiple of 3? Colton? Let's think bigger because we want to get rid of as much of this. You're right, 15 would work, but go as big as you can without going over 102. Todd?
99.
99 is also a multiple of 3, but let's do 90 instead. And let me show you why. So Todd, you can give yourself a point as well, and Colton. Let me show you why we're doing 90. Because I don't want to do complicated subtraction down here. I want to do simple, because if we have to borrow and all of that, go next door and decompose and all that, there's more opportunity to make mistakes. This is already, Zerelda, a really complicated, long process. I don't want to add other opportunities to make mistakes in here. So, what do you multiply 3 times to get 90? Evan?
30.
Uh-huh. So that 30 we just wrote down comes up on top of the 200. Now, what is 2 minus 0? 2. And then I'm going to do 10 minus 9. 1. Now we're just left with 12. Is 12 a multiple of 3?
Yes.
So we're going to just subtract 12. What do you multiply 3 times to get 12? 4. And that 4 is going to come up here. And then 12 minus 12 is 0. 200 plus 30 plus 4 equals?
234.
All right. 234. And then we got a box around it. Okay. So, when you're doing a partial quotient method in your workbook, you want to start in the middle of the page because you're going to be moving down, but also moving up at the same time. 702 divided by 3, we started by taking away 600. That left us with 102. 3 times 200 gives us 600, so we put 200 on top. Then we took away 90. That left us with 12. And 3 times 30 is 90. And then we're going to take off 12. Whoop, 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 whoop. I lost my train of thought there. We put our 30 up here. Sorry about that. Then we subtract 12 because 3 times 4 is 12. And we put our 4 up here. So our answer is 234 with a box around it. You guys remember on the mouth warm-up where a few of you commented about how the equal sign was in a different spot than normal? We'll give it 600 equals 3 times 200. 90 equals 3 times 30. 12 equals 3 times 4.
Oh, that's why I was raising my hand. I noticed that.
Cool. All right. Did you guys get that copied down? Okay. Here we go. Is 702 a multiple of 3? Jackson?
Yes.
How come?
Because
What did we get at the bottom?
we got a 0, no remainders.
Exactly. Exactly. So is 702 a multiple of 3? Yes. Because there is no remainder. All right. Now, next we're going to look at Andre and Alina's work. Andre and Alina are dividing 2,316 by 5. Before they begin, Andre says, I can already tell that there will be a remainder. Do you agree with him? So if we're dividing 2,316 by 5, are we going to have a remainder?
Yes.
And it has nothing to do with even and odd. How do we know, Harbor?
Because we have a 5 and a 0.
In the what place? Yes, girl. Yes. Multiples of 5 have a 0 or a 5 in the ones place always. Does 2,316?
No.
Nope. So we're going to have a remainder. Okay? All right. Good work, Harbor. So, Andre is correct. Multiples of 5 have a 0 or a 5 in the ones place. $2,316 does not. So it is not a multiple of 5. Yes, Ava.
Why did you cross out the 0?
So it doesn't look like a letter L. The letter O doesn't get a line through it, but zeros do. So you can determine the difference. Audrey?
Does it matter which way you put the line through it, like that or like that? Which slanted way?
I don't think so. That's a good question. I don't know.
Let's ask Siri.
Let's not shout. You're gonna wake up Siri, and I don't even want to talk to her right now.
Why?
All right. Here is Andre and Alina's work. Each student made one or more errors. Identify the errors each student made, then show a correct computation. So this is kind of what teachers do all the time, is look at a student's work and see, and if they made a mistake, find where the mistake was. So this is a big part of teachers' job. And usually what I do is I'll do it correctly the first time and then compare. So that's one way you can do it. For time's sake though, we're just gonna go through and see what they did. Just start like normal. Okay, so we have Andre first, is that right? Okay. Andre, he was the one that figured out that 2,316 would have a remainder. So he's doing good on this division stuff. So let's see where his mistake was. Okay, so he set up the problem with the 2,316 divided by 5. He first subtracted 2,000. Is 2,000 a multiple of 5?
Yes.
Yes, because you can't multiply 5 times anything and get 2, but what can you multiply 5 times and get 20? 4. So that means 5 times 400 would be the expression for 2,000. What did he do? What'd you do, Devin?
I'm bleeding.
I see that. Do you know what you did?
No, I don't know what I did.
Okay. I'll give you a paper towel and you can go.
All the way down there.
All right, guys. Here. Stay in your seats. Those are rolled up. Put the, blot it up and go to Nurse Katie.
Is that a lot of blood?
Enough. Okay, okay, go on to Nurse Katie. Just tell her Miss Peterson's in the middle of teaching math, okay?
Okay.
So I didn't write you a pass. All right, back on track, guys, or we're gonna have to start all over again. Okay, so, he subtracted 2,000. We just figured out what you multiply 5 times to get 2,000. What's his first mistake? Who sees it? Athena?
He subtracted 15.
No. Jackson?
He put 40 instead of 400.
Yep. So you see it up at the top? We're supposed to write 400 up top. He just wrote 40. So that was his first mistake. So this should be a 400. Next then he did the subtraction, got 316. Then he subtracted, he chose the number 300. Is 300 a multiple of 5? Does it have a 5 or a 0 in the ones place?
Yeah.
So it is a multiple of 5. What do you multiply 5 times to get 300? If you do not know, ask yourself what you multiply 5 times to get 30. 6, and then you add on it. It would be 60. And then he did that correct, right? He put the 60 up here. 316 minus 300 is 16. And then he subtracted 15. Is 15 a multiple of 5? Yes. What did he multiply 5 times to get 15? 3. And that is good to go. Okay. So, and then when he subtracted, there's his remainder that he predicted would be there of 1. What's 400 plus 60 plus 3 equal?
463.
463. So the correct answer should have been 463. Okay, then let's go look at, is it Alina?
Yeah.
Alina's work. Okay, she started by taking away 1,500. I'm not a fan, Athena, of her taking that away because 5 is bigger than 3, so we're going to have to regroup. We're going to have to decompose. So, but you can. Is 1,500 a multiple of 5? Mm-hmm. Yeah. What do you multiply 5 times to get 1,500? Close the door, please. What do you multiply 5 times to get 1,500? Zerelda?
You have to.
My question was, what do you multiply?
300.
Very good. Yes, 300. And so she put the 300 right here. And then did the subtraction. 6 minus 0 is 6. 1 minus 1 is 1 minus 0 is 1. Then 3 minus 5, we would have to turn that into a 13. Minus 5 is 8. All right, then she did subtracted 500. What do you multiply 5 times to get 500? Harbor?
100.
100, yep. Because 5 times 1 is 5, and then you match up the zeros. And then she put a 100 on top, and then she subtracted 300. And what do you multiply 5 times to get 300, Evan?
60.
Yes. And she put her 60 up top. And then she subtracted and got 16. And then she stopped. Harbor?
The problem is that the number at the end has to be less than 5.
Less than 5. Exactly right, Harbor. Great job. Yes. So she needed to keep going. She needed to subtract more. So what do you want to subtract? What's the biggest multiple of 5 that you can subtract from 16? Jackson?
15.
Yes. So I'm going to put subtract 15 equals 1. And then over here, what do you multiply 5 times to get 15? Evan? 3. And so up top, she only added those two numbers together, didn't she?
Yeah.
So she left off the 60 and the 3. So she left off the 60 and then the 3. Okay. All right. Let me see where we're at. Okay. Here are 4 calculations to find the value of 3,294 divided by 3, but each one is unfinished. Complete at least 2 of the unfinished calculations. Be prepared to explain why you chose them. We're going to do A because I like A. This one, they broke it apart too much. Do you see how they, so we're gonna do A. So they first divided 3,294, they divided by 3, they took off 3,000. And the multiple, or 3 times 1,000 is 3,000. That left them with 294. Then they took off 270 because 3 times 90 is 270. So they put the 90 up here. What's 4 minus 0?
4.
And 9 minus 7? 2. Is 24 a multiple of 3?
Yes.
Yeah.
So let's take off, do our final subtraction to get to 0 and take off 24. 3 times what equals 24? 8. So I'm going to go up top and write an 8. And then 1,000 plus 90 plus 8 equals 1,098. Good. 1,098. And then we're going to put a box around it and our comma. Okay, so we're going to skip over B and we're going to do, we're going to skip over C too. And we're going to do D. What she did is she took 3,294 and she turned it into a subtraction problem. So she, which if you do 3,300, this is what she did. She said 3,294. That's really close to 3,300. And I know it's really easy to multiply and divide numbers when they have zeros. So I'm going to turn this number into this number. But I still have to take off the 6 because it's 6 more. So 0 minus 6 can't do it. Borrow from the 30, make it 29. So now, 3,300 minus 6 equals the number we needed to start with. Then she's going to divide each of those by 3 and get 1,100 minus 2. So right here we need to put,
Are we going to see?
I need you to stop talking. 3,294 divided by 3. And if we do 1,100 minus 2, that equals, bless you, 1,098. This is really similar to when we were splitting multiplication problems all year long, how I've told you we could, if you don't know how to multiply, you can multiply by splitting it into 20 plus 3 and multiplying each part by 4, right? So that's what she did here. She said 3,294, I'm going to turn that into 3,300 minus 6. Then I'm going to divide each of those by 3 because I know they're both multiples of 3, and then subtract since there's a subtraction sign, subtract. We're not going to do C, Zerelda, because they told us to choose 2. All right.